Welcome to SkyWeek. I'm Tony Flanders from Sky and Telescope magazine, and I'll be your guide to the astronomical wonders that are currently on display overhead. Let's see what's happening in the sky from Monday, February 17th to Sunday, February 23rd. The waning gibbous moon rises around 9 p.m. on Monday and around 10 p.m. on Tuesday. On Wednesday, it rises around 11 and isn't reasonably high until midnight. But it's worth staying up late because you'll find two bright points of light above the moon. The bluish star on the right is Spica, and the brighter point of light on Spica's left is the planet Mars. It has just recently become visible in the evening sky and is brightening rapidly. Mars is now a little brighter than similarly colored Arcturus to its upper left. A month from now, it will be more than twice as bright as Arcturus. You can find Spica and Mars side by side in the east at 11 or later any evening during the next month. But they're especially easy to identify early this week, with the moon to point the way. Take a look at the constellation Orion before the moon rises and starts to light up the sky. Dangling from Orion's belt is his sword, a line of 3 or 4 stars. Can you see a little cloud of light around the next to bottom star? If not, you can surely spot it with binoculars. This is the Great Orion Nebula, which is giving birth to new stars right now. It appears red in photographs, but through a telescope, it's either pure white or perhaps slightly greenish. It's one of the loveliest sights in the sky, rivaled only by Saturn, the Moon, and perhaps the Pleiades star cluster. Cameras are much more sensitive than human eyes are to the red light, which is the glow of hydrogen gas ionized by the ultraviolet radiation pouring out of the super-hot young stars of the trapezium, much like the glow of a neon light. Wherever you see red or pink glows like this in astrophotos, it's a sign that new stars are being formed. Let's see how that works. It all starts with the gas that pervades our galaxy. It's fantastically sparse. A thimbleful might contain just 1 or 2 atoms, compared to 100 billion atoms for a thimbleful of air. Air molecules are constantly colliding with each other. But in most of our galaxy, an atom can go thousands of years before it hits another atom. And if the atoms join up to form a molecule, pretty soon a photon of ultraviolet light from a distant star smashes the molecule apart again, just as UV from the sun produces ozone in Earth's upper atmosphere. For reasons not fully understood, this gas sometimes clumps up into clouds that are hundreds or thousands of times denser than average. All the stars of Orion, and more, lie right in front of a cloud hundreds of light years across, called the Orion Giant Molecular Cloud. The Orion Molecular Cloud is still incredibly sparse, 1 billion times thinner than the best vacuum we can make in a laboratory on Earth. But it's dense enough so that the atoms start to bump into each other and combine into molecules faster than they can be smashed apart. Molecular clouds also have dust particles, actually more like fine soot, which absorb light very efficiently. So most molecular clouds are visible only as dark patches that hide the stars behind them. But when molecular clouds are particularly dense, gravity causes them to collapse into star clusters. These light up the surrounding gas to produce gorgeous nebulas like the Great Orion in the winter sky and the Lagoon, Eagle, and Swan in the summer sky. Next week, we'll talk more about how stars are formed. Until then, this is Tony Flanders from Sky and Telescope magazine, wishing you clear skies and great views.
Brought to you by Woodland Hills Camera and Telescopes, serving stargazers since 1952.